Hey, today on SolarEmmet.com. No, I'm just kidding. It's not SolarEmmet.com. But I am Emmett, and we're going to talk about solar. We're going to talk about solar. First thing I want to talk about is people in solar. So there's two factions. There is the constituency who knows solar, how to sell it. Then there are people who know how to install it. And then there are people who know the science behind it. Sometimes people have two of the three aspects, but they all most of the time they have one. So what I want to show you is that the solar inverter manufacturers, the racking manufacturers, the people who supply the equipment for solar have some great tools for you to be able to design a system so that you can know how it performs, how it's put together, the bill of materials, generate a bill of materials if you're doing a project, if you're doing one for your home, if you're doing one for business. All this applies to the same thing. I'm going to use SolarEdge today to begin this tutorial. So we're going to go to www.solaredge.com. Boom. And once my computer catches up with me, here's a really cool thing. SolarEdge has a designer tool that allows you to design for your home. And I've done one earlier, but I'm going to redo it again. And what that's going to encompass is I must know the address. This is so critical to designing your project. I'm looking up the address right now for what I'm going to be designing for. So I'm going to go into the designer. I've already registered. It's a quick process. They ask you a few questions. It's really not that deep. And you have to generate a password. They give you approval. You're in like Flint. I'm going to call this Detroit Project 2. And my coordinates, the address is 20734 Lee Court in Grosse Point Woods, Michigan. And this is a cool house because it's got a lot of exposure to irradiate to from the sun. And oftentimes what I will do is I will take that very same address, I will copy it and bring it into Google and get a street view of it so I can get perspective. This is really important because you need to know where the house is. So that's the house that I am looking for. I saw in the back that there's a tree and then there's another tree over here, but pretty much this roof is exposed. Now let's go back. What you will notice is that we are looking from the north-south perspective at the house, and this is east-west. So let me make that a little smaller here. Now, I know that this information is correct. I know what weather station it's using, and the reason it needs to use the weather station because it has to take into consideration snow weight, wind factor to create this project. Now, further down, I can enter the customer's name, Johnny Wick. No, Doe. And it's a Doughboy company. If you're from Detroit, you'll get that reference. You can also input your annual consumption and make a consumption profile. Now, I want to tell you about the difference between residential and commercial. The difference between residential and commercial gives you access to different products because the residential relies on 240 split phase, 208 line to line, and 120 line to neutral, which is a Y configuration. There are some that will give you a 480 or a 208. And particularly when you go to the commercial side of it, your inverters actually can increase in size that you don't have access to. So once you go to commercial, then you have access to the 20 kilowatt, the 33 kilowatt, and the 66 kilowatt from SolarEdge. You can also put notes in here. This is a test. I don't export my limits. I don't do any of that. This is just the basic stuff to get everything keyed up. Now, earlier when I was trying this, see, this gives you the perspective so you can turn your perspective of how the house is going to be laid out. And what I want to do is look at my roof plane. So I know that there's a pitch here. There's an A-frame pitch here, and there's an A-frame pitch here, and it's like a 112 pitch. So it's your standard American house, single slash bi-level home. The next, now that we've seen the picture, we know how it's laid out. We can see that we have obstructions over here. So we're not going to put any modules there because there's some shading that's for a good part of the irradiated year. And over here, there's a little bit, but it's not going to give you that much because your sun travels on this side and the shadows would be cast over here, as you can see from this tree. So now that I know that, I'm going to trace out my roof. So I'm going to start at the top of the roof, work my way across, work my way down, and I came a little bit wide, but that's okay. Come over, make myself a nice square because that's a nice plane. Even if you have multiple pitches, you can come around these pitches so that you can place a single module or two modules. It all depends on what you're working with. Now, once I have that, I like to zoom in a little bit so I can tidy things up a little bit. So it's 36.9 inches, and I want to move it in a little bit. Move that in a little bit, and square it up. Ah, sometimes it can be a little tricky. Now from here, I'm set to place my modules. Actually, I want to bring this down a hair to the edge of this roof. 13, 14. Now I got it relatively square. So I'm going to go to my module, PV module placement tab. And from here, I can select my module. What I will do is I'll select the roof plane that I'm going to be working with. I'm going to hit add PV modules. I'm sorry, I missed a step. Now I can pick, I'm a Q-Cell fan. I like Panasonics too. I'm going to use a 385. And I'm going to start out and try with a tilt dip. Now, you'll notice something. When you have a flush mount, what it does is it takes away your ability to adjust the azimuth and tilt in your frame. I like using the tilt dip because I can always come back. I'm going to put an inch between column space and row space just to give myself a little leeway for my racking so that it gives me a little bit of play when it comes to my mid clamps and my end clamps. Now that I have those, what I can do is I can turn this around. So now I can draw my modules, come to the very corner. And you see how it gave me that weird layout because it's thinking I'm in my original position. So if I do this and I come back, and what you want to do is try and match up how your modules are going to be laid out. This could be a little bit tedious sometimes, but pays off in the end. Now you see how it kind of worked out. But I'm going to show you a trick. You can get rid of this because you've already carved out your roof space. And you can go to grid view. Turn your grid view to a nice even keel. Come up here. And it draws them a little better. I can pick my modules, portrait or landscape. Change my azimuth a little bit. And the only reason this came up this way is because I have it in tilted. So if I get rid of these, boop, and I want to draw my modules now. Oh, I forgot something. And I come back over here. and I select flush mount, see how even it became? Now, I don't like this configuration. I don't, not at all. So what I'm going to do is I'm going to turn them to portrait. And I can keep adjusting until I get everything to fit just how I want it. So I can come back over here, can adjust. Now here's a problem that you may run into. Sometimes computers and human intelligence don't quite match up. You see, we had some little issues here. I mean, you can play with them over some time and get everything exactly how you want it, as you can see here. So I want that module and I want that module because I know I can put two more modules in this space. So from here, what I'm going to do, come back here, doesn't like me. Now, some of this you have to play with a little bit so you can move everything around, see how they're going to fit. Now you see that we have this scenario here where everything's in place. If it falls outside of your boundary, what you'll get is a little red item to say, that's not going to quite work out so well. So I've even added another module in. And if I could just tilt this a little bit more, then it would give me a little bit more play. But we're just going to work with that. So we have a string of 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, string of 9. And the reason I'm showing you is because these are little obstacles that you'll run into. You will literally run into these obstacles. But they can be corrected with just a little bit of time. So if I would have added that one more module, I probably would have hit that 125% oversizing. And what that's for is for 365 degrees of your system. When 365 days of irradiance, because in the summertime you have direct sunlight and it's high in the sky, but your modules get hot and they don't have as high a voltage. In the wintertime, you don't have as much irradiance, so they don't produce as much current, but you can have a scenario of cold weather. Cold weather actually makes them perform better. Even though you're not as irradiated, you want to design so that in the summertime you don't get so hot that your inverter shuts down because the voltage drops low. And in the wintertime, you can get a scenario because of the cold weather. Even though the sun is lower in the sky, you don't get as much radiance. The cold weather can boost up your voltage and you can have more power than your inverter or your electronics can handle. So I'm just going to generate with this. And this is just a quick and dirty guide. So now it's chosen a 6,000 watt inverter, and I am going to add my optimizers in, which is a P505. I'm going to come here and you see what happened. If I didn't have enough modules, the string is too short to connect the optimizers together, it'll give me orange. As soon as I get into where it's functional, it'll turn green. Now I can make this one continuous string, but a problem will arise when I hit the 17th module or 16th module is it's too much power. So what I will do is do a string of 10 and a string of 9. And now this is a cool thing that's good with an inverter that has optimizers because now you don't have to have even strings like you do with a string inverter, traditional string inverter. So what SolarEdge has basically done is taken the peanut butter and the chocolate, put them together, and made a Reese's Pieces or a Reese cup. So now that I had that, I'm happy with that. If I was to do another plane on this roof, I could just add another inverter, or I could probably tie it in with here because of the optimizers. So now I can come down here and I can look and I can see how my system is going to perform. It's going to show me my modules on the roof. And another thing that I didn't show you is that I can actually change it and show that this roof has a pitch. And what I've done is gone up to the site modeling. I'm going to connect with 3D and it's going to give me this. And now I can drop this down and get me an angle. Boom, boom, boom. That's about right. This is for demonstration purposes. And I can come back into my system and look how they've matched up. How boss is that? Still won't add it. It just doesn't like me today. Come back down here. Still have my strings together. See my summary. And I can get a layout of my house. See how that works? Now I have a bill of material. I know that I need one SolarEdge 6000 HD Wave US inverter. I need 19 P505 modules, and I am going to need 19 Q-Cell Duo LG5 385-watt modules. All right, the next thing we're going to do with this project is we are going to do a racking demonstration. So now that we have our modules for this, we're going to add racking so then we can comprehensively put these modules on the roof along with our inverter that will go and put it in the house. Till next time, stay tuned for Solar Emmet. Those of you who know me know I've been in the solar industry for quite some time now. So you've probably been to some of my classes, which are pretty lively, and we talk about all these things, but the solar industry changes so fast because of regulations of safety, grid parity in some places, how people are using the energy. You have to stay tuned and abreast of what's happening in the photovoltaic field, and that is part of my mission here, is to enable you guys so that you can be well prepared and well versed in how to apply knowledge to your PV systems, your PV business, or just your home. Till next time, see you then. Racking.